So we don't know what u is, we don't know what v is, but we're asked to find the derivative with respect to x. So u and v, we're assuming are some sort of functions of x, but we just don't get to look exactly at how they're defined. That's okay. We can still write out what the derivative is going to be using the letters u and v. Look, this is the quotient rule. That's all they're asking you to do here. The derivative of the numerator times the denominator kept the same. So u prime v. That's the derivative of the f of x, like the top one, divided by the g of x, the bottom one, subtracted by u times v prime, just like the quotient rule says, and it's all over v squared. Okay, so that's the derivative. We don't know what it is, so we can't expand it anymore. We don't know what u is in terms of x and what v is in terms of x. But now we can do what they're saying. Find the following derivatives at x equals 0. They give us a bunch of values at x equals 0. They're saying u prime, the derivative, is negative 3 when x is 0. They're saying v at 0 is negative 1. Negative 1. They're saying u at 0 is 5. And they're saying v prime is 2. And that's all over v squared. So v at 0 is negative 1, so that's going to be negative 1 squared. Okay, so it's really just a bunch of plug and chug, just trying to force us to use the quotient rule because, well, I guess you could rewrite this for the power rule too. But negative 1 squared is 1, so 3 minus 10 is negative 7 is our final answer. Okay, so dx of the next one over here, this is, well, I want to do one with the product rule. Let's change that. Let's do dx, where it's 2uv. That way I use the product rule. Look, if there's a constant multiplying to your derivatives, this does not affect the rate of change with respect to x, right? Because it's not in terms of x, it's just multiplying by 2. So this is a property of the derivative operator. The 2 can come out and multiply. And so now you can take a derivative of this entire inside, make sure to wrap it in parentheses because the whole thing is being multiplied by 2. But now we can take a derivative of the inside using the product rule. The derivative of the first function with the second function kept the same, plus the first function times the derivative of the second function. And if you're not sure where I'm getting that from, you'll probably want to look up the product rule, just to refresh yourself with that formula. It's usually written as f prime x times g of x plus f of x times g prime of x, which is what I've done here just in terms of u and v. And again, they've given us particular values at x equals 0, so now we just need to plug them in. The derivative of u is 5, and then the derivative of v is negative 1 at x equals 0. And then u, oh, sorry, that's not the derivative of u, that is u. So the derivative of u is negative 3. Negative 3 is what I should have wrote here. Okay, over here, this is 5, and then v prime at negative 1 is 2. Okay, so negative 3 times negative 1 is 3. 3 times 2 is 6. Oh, wait, I don't want to distribute it. I'm going to mess myself up. This times this is 3. This times this is 10. Okay, so that's 13 times 2. So 26 is my answer here.